All right, we're back. Channel 9 Live, build. I think it's 2017, man. It's crazy. It's been a while. And we're here to take questions from the audience. We want to talk about Azure Functions, AKA serverless computing, maybe the other way around. So with us, we have pretty much the inventor of Azure Functions at Microsoft, developer. So please ask technical questions.
Yep.
And of course, we have the sort of the visionary management here.
Yeah, management overhead.
So let's, no, I wouldn't say overhead. I mean, so let's talk a little bit about what is an Azure function, and then we'll get into let's start with serverless computing, actually. I mean, I hear this term everywhere, serverless computing.
Yeah, so I think by now serverless computing is sort of like cloud or agile. It's been serverless washed.
Yep.
So everyone's serverless, which is awesome. If you look at the strict definition, it's sort of three things. One is the programming model, functions as a service. And you see people starting to call that piece functions as a service. So event-driven, small functions, unit of execution. The second pillar, if you will, is the auto-scaling. So the ability to not worry about infrastructure at all.
Okay.
So that's where the serverless thing comes from. You don't know about your infrastructure, and the platform auto-scales you based on demand. So that's sort of pillar two. Pillar three is pay-per-execution, which means you only pay for the time your code is running, which is much different than what we're used to in the cloud, which is essentially, and I love that because we're in the cloud business, but you rent a CPU from your cloud provider, and it doesn't matter if it's running your code or not.
Okay.
Serverless is disruptive because you only pay for the time it runs.
Okay. And so, I mean, functions, when you execute code, you need memory too.
Yeah.
So I might have a function that requires a relatively large amount of memory because I may be operating over a large piece of data. I have to bring it, stick it in RAM, parse it, do whatever I want to do. So I'm also paying for memory usage, right?
Yeah.
So what? How does it work with a function that's going to take lots of different endpoints? So I want to run a function that's going to, I want to have a concurrent system set up. How do you guys deal with that in your functional world?
I mean, so generally it's about just you define your functions, you define what's going to trigger the functions, and then your memory ends up getting decided by us. What we see your system trying to consume, we actually go through there and try to scale the system such that we meet your memory needs to an upper limit of I think 1.5 GB per execution.
Okay.
And that allows, we basically charge you for what we use. So if you use less memory during execution, if you use more during memory during another execution, that's what you get charged for. And then to manage lots of various concurrent executions going through there, you don't. We do that. So as an execution comes through there, we manage whether or not it's running on another server, or this server, that server. It's all controlled by us.
And so in the case of like .NET, right, which a lot of .NET developers everywhere, obviously you have to have namespace, class. So you have anonymous classes. I want to get into the meat of actually what is an Azure function. How do you guys actually do this? And let's start with the .NET as an example.
Yeah. So I mean, in the case of .NET. And let's take C# specifically in .NET. We've also have F# support as well.
Cool.
With C#, you've got two ways. The way that most people get started with functions is with C# scripting, so like CSX files. In which case, we kind of follow the normal C# scripting stuff where you can like &R additional things. You can import other libraries directly. We can use the, we still use the project.json format to pull in NuGets for now. And we'll go ahead and compile that. And essentially, it results in a single method, a run method that we load in for C# scripting.
Okay.
When you use compiled assemblies, what you do is you just essentially give us an assembly, and then you tell us what class and what method you want out of that assembly. And you give that to us in a config file, essentially. And we'll go ahead, load that assembly into runtime, go find that method, and every single time an event comes through there, we call your method on your assembly with the data.
Cool. Is it one CLR per function?
You can do
How many CLRs are running?
You can do a single assembly for all your functions. You can do 2 assemblies for 2 functions. You can mix and match as you'd like.
Great. All right. Dan wants to know, can we expect a better build out of SSIS type functionality in Azure?
I'm not sure.
What is SSIS?
Server integration.
Oh, you mean the Starship? Yeah, that's coming soon.
Yeah.
So that's a great question, Dan. What we'll do is we'll hold on to it and figure out what you're trying to ask. But for this thing, we want to talk about Azure Functions. We want to talk about serverless computing generally.
Yeah.
We want to talk about how you can put different clouds together. Like that's always interesting to me. Like I want to use an Azure Function is just an endpoint, so I can have a trigger anywhere.
Yep.
Right. I can be running something in AWS that's doing blah, blah, blah. I'm going to take advantage of Azure Functions to do this, Google Cloud to do that, build this sort of kind of heterogeneous, interesting monster. And so how do you guys test scale? How much can you guys really scale?
I mean, we'll just throw as many messages at the system as we possibly can. I actually have a really cool test that I do. I call it the exponential scale test, where essentially I take a queue, triggered function, and I have it output two queue messages back into the same queue that it was triggered from. And so essentially, by a queue message creating two more of itself, it just, boom, explodes out exponentially every single time that it's invoked. And I just set a max generation count on it, so it eventually does kill itself, because otherwise it would tear down the entire internet. And that's, that thing will go through there and run 2 to the 20 messages, all in the kind of, just scales out immediately, runs all the messages, and then kind of scales back down after those messages are done.
Okay.
We've got people who are running, 1 billion executions in a given day. And not ever having to call us to figure out how that worked. They just kept on throwing more and more messages at it, and we kept on scaling more and more.
Awesome. Excellent, man. All right. And so here's what I want to say. Steven PSA wants to know, as I understand Azure Functions, it's mostly about in the background. Is there a role for function for app I/O, data ingress, egress, etc.?
Yeah, I mean, those things work just fine as well. Azure Functions works really naturally for background processing because things like queues just works great and naturally for that kind of process. But we also have plenty of examples of people who have used like HTTP functions to upload like media, like video and photos and things like that, do some light processing, and then also upload that to blob storage afterwards. So there's really no limits to what you can do in that kind of space. Functions definitely kind of came from the background computing space that's evolved from web jobs, which is the underlying technology, which was designed for background computing. But we've gone through there and brought all the goodness of like, HTTP triggered functions, which can do anything that you would normally do in like an ASP.NET application.
Cool. Bill wants to know, how do I choose a web service versus a function? If I have a web service in Azure driven by a queue, how do I convert it to a function, and how can I compare the performance, scalability, and cost?
So as far as how you would convert it, essentially I would start by just starting one at a time. I like to move from the back forward, so I can go ahead and replace the back end piece there that's listening on the very last queue with a function. And then I can replace the next thing up the chain that was producing that queue message with a function, and presumably that's listening on a queue as well, and kind of work my way backwards like that until I get to the place where it stops making sense to add functions. Sometimes it still makes sense to have a normal web app. I've got a lot of existing investments in my web app, and I don't want to necessarily move that one into functions. It's okay. You can move just up the chain as far as you feel like, and then stop and pause when you want to. They really work well with existing infrastructure because it's an extensibility kind of play with
Absolutely.
functions.
As far as the cost, we offer a very generous free tier. You can have 1 million executions a month for free. So a way to test the cost is it's pretty cheap to get started.
But I mean, so my execution could last for 100 days. So in other words, the number of executions, it's also like how much compute I'm using?
Actually, we have a unit of measure which is the millisecond and the amount of memory you consume. And it's called GB seconds, and the cost goes up as much memory as you consume per millisecond. We won't let you run something for a month, alas. We kill you after
Don't use a different
3
thing,
minutes,
don't use a function.
So in consumption compute right now, the time limit's currently 5 minutes per execution. When you're running on dedicated compute, you can run for as long as you want to, but keep in mind that you're running on someone else's VM, if you will, right? So we might pull that thing down to update it and things like that. So you don't generally want to write code that's going to run for like 2 hours in a single execution. You would go break that up into many different steps using like queues to do fan out to break that work up into smaller pieces. And that way, if let's say that function fails halfway through, if it was going to run for an hour, you've now got to run and you failed halfway through. Now execution is going to take an hour and a half if it succeeds the second time, right?
Sure.
If you break it up into queues, it's more reliable. If one piece fails, the rest don't fail, and that one can retry itself and catch up. And you've reduced your end-to-end processing time.
So I guess the idea then is these are really like micro computational bursts.
Yeah.
This isn't about, hey, I can write any code I want and not have to worry about all the infrastructure. Actually, no. You can write a function and do what a function's supposed to do. Now, I know I've written plenty of functions that take a long time to execute.
Yeah.
So as a developer, you have to understand that doesn't make sense to run that in a serverless environment. So nice to see you too, Steven and company.
Yeah.
Any progress on the mitigation of cold boot time of Azure Functions?
Plenty of progress coming in small increments. So I think we've made a lot of progress in the last, 4 months with many changes. Probably don't want to go into details, but we'll
Okay.
People will see it as it goes along.
For the most part, cold start is composed of 3 different parts. It's when we have the VM available, when can we have our host that's on the VM up and running, and then when can we go ahead and instantiate your code. We're making really good progress in making sure that the VMs are as warm as possible, so that is as small as possible. We've already got our host, shrinking it so that load time is as small as possible, and we've invested in tools like the precompiled assemblies, so you don't have to compile each time the function comes up, and things like we can webpack Node.js functions for you, so that way you don't actually have to load the whole Node.js npm dependency tree. You'll just have a single JS file that you end up loading into memory, and so it's much, much faster to load. So we're making good progress in kind of all 3 of those spaces, and we'll keep on kind of pushing it down so it gets smaller.
Now, we haven't talked about it yet, but we probably should,
Yeah.
right? The marketing side of things, which is very important. And that is the announcements that you made today. So some of them around containerization. Can you talk a little bit about what announcements you made so that we can get that out?
Oh, for sure. So, because there's a lot of questions, which is nice.
Yeah, so we want to get to these questions, so let's do a quick...
Sure. So I think there's sort of 3 pillars for the announcement, if Chris can go into details, but one is our continuing investment in development tools. So you're seeing our new Visual Studio integration, where you can essentially F5 a function, and from now on, even I can write it and debug it.
Awesome.
It's all about me. So we have it in Visual Studio. It creates those precompiled assemblies that you can deploy into a function. And because it's precompiled, then you're getting all the mainstream C# functionality or .NET functionality in Visual Studio. Test harnesses, IntelliSense, what have you. So that's one big piece. The other one is around ALM, the Application Lifecycle Management. We introduced the capability to do pre-production environments that are called deployment slots, which is a concept we brought in from the app service area. And that allows you to do a pre-production environment for a function and also split the traffic between vNow and vNext and control the percentage of traffic that will go for each. And then you can either script or through the portal do what we call a swap, which puts your new code in production. And we take care of warming up the new code and draining out the old code. So that's very exciting because now you can actually do real applications. You can set up it in Visual Studio, use VSTS to do your builds and so on, and push into your pre-production environment, test it automatically, and then go to production. So that's kind of pillar 2 is ALM. The last one is sort of aspirational, and we're very excited about it, is the Azure Functions runtime. So sort of connected to Satya's keynote about the intelligent edge. We're imagining a world where these functions run really everywhere. So that's the code name for this project is Functions Everywhere. And we're making our first step by providing an installer that allows you to set up either an Azure Functions server on your Windows 2016 box, or what we call a function worker, which is a smaller version of the runtime that just listens to event, and that runs on Windows 10 creator update. Those things do launch in containers, in Hyper-V containers.
Nice.
And it includes some limited functionality around managing the workload. So if you publish a function into that server piece that you can do from Visual Studio, you can configure the workers to listen to that guy and run your stuff. So imagine sort of the SETI as a service. You can have all of your machines at home. I'm sure you have plenty of them.
Yep.
And who doesn't want a function server at home, right?
That would be great.
Or
I'd
two.
love.
Yeah.
Brings up a whole nice new security thing to think about.
Exactly.
I enjoy that.
So now you can run all these batches completely on-prem
Awesome.
and use the same programming model in Visual Studio. So very excited to be able to announce that. And then there's a question there about where it's coming for Linux. So that sort of links to that because you'll see us very soonish provide this runtime on Linux containers as well. So then you can have it on a smaller footprint devices like this IoT Edge that was also announced in the keynote.
Great. Really
so
good.
Marketing stuff out of the way.
No, it's nice. I mean, it's sort of like an evolution of web jobs in some sense. So is Azure Functions ready for use in healthcare? So, you know, the HIPAA requirements, got to be protective of people's personal data.
Yeah.
So in general, Azure App Service is HIPAA compliant. I think because functions, a new feature, we need to go to the next audit cycle. So we'll have to check on the dates because someone asked me in the booth the same question.
Okay. We're going through the process right now.
Oh,
so
okay.
you can look to see some news, hopefully in summer timeframe.
Okay.
Great. Next question. Is Azure Functions limited by some execution timeout or max request length?
Yes, we have both. So for timeout, you've got the 5-minute timeout right now. We might extend that in the future. And then for max request length, we also have that. I forget what it is off the top of my head. It's documented somewhere online, but it's a couple. I think it's like maybe 25 megabytes, 100 megabytes. I can't remember which one of those it is.
Okay.
So if you do have something which is larger than 100 megabytes, you'd have to split it up into batch uploads.
Excellent. Hello. When will Azure Functions? We already talked about that. It's coming to Linux. Great. As was mentioned, that assigned resource for executing functions are covered by Azure. How to predict the cost of using functions? So I want to know ahead of time how much my function is going to cost.
Yeah.
So there's two ways to address that. One is if you know that you're going to run it for a long amount of time, it's actually cheaper to go to what we call a app service app hosting plan, where you rent the CPU from us just like with the web app. So that's available to you. So we're actually cheaper in bulk than the competitor. The other way to do it is there's actually a not so well documented feature there where you can set a cap for how much money you're willing to spend.
Yeah.
So that's on a daily basis? Or?
Yeah, it's a daily basis.
Yeah. So you can basically say, I don't want to spend more than $5 a day, and that's it. You put it in the portal.
How much computing does $5 a day get me?
Oh, well, do you have your little calculator?
Yeah, it's,
You have the all figured out?
You get 400,000 gigabit seconds free a month.
Okay.
That equates, so 400 gigabit seconds is about 7 days of continuous computing if you were running a 128 megabyte GB sec thing just end to end all the time. So
Nice.
7 days of 128 all the time for free every single month.
Nice.
So that's a lot.
That is. So use it. Take advantage of it.
Yeah.
You can do all kinds of creative things. What about performance, right? I need to spin up a DB connection for each call. So
This is actually a great one because the nice thing with functions is we do keep the functions instance that's running your code live between requests. So if you have something which is like a database connection pool that you want to keep alive, you can go ahead and wrap that in a factory model kind of thing, have each function go through there and request from the factory an instance of the database connection pool, and it'll be kept alive between executions so that way it doesn't get spun down each time. So you do have some more caching that you can do between calls to improve performance.
absolutely. And let's be honest, state is useful.
Yeah, exactly.
Is there any dashboard like web jobs to see if there was execution errors showing stack trace, etc.? So they showed a really cool demo today. Scott Hanselman did.
Yeah.
Of debugging in real time, seeing exceptions, getting stacks, etc. Can we do the same thing with Azure Functions or something similar?
Yeah, so Azure Functions, does have the Web Jobs dashboard, by the way. So if you do the Web Jobs dashboard, it's still available for you in Functions.
Okay.
The monitoring tab has it, and you can go back to the normal SCM site / Azure Jobs endpoint to get that dashboard. We also announced the Application Insights integration today, and that will allow you to go ahead and see a live metrics view of what's happening real time across all of your apps. So if you have exception messages being thrown, you'll actually see your exceptions being streamed into the portal in real time from all your various instances,
Great.
as well as CPU percent utilization and memory per instance you're on under the covers. So even though it's serverless, we'll actually expose you the information per server that you're running on under the covers.
Which sort of begs the question, how do you do remote debugging in a serverless environment?
You can actually remote debug. Right now, it's only .NET applications.
Okay.
Node.js will be kind of coming here soon. So you can actually just attach a debugger. It's a little bit weird because if you're running under high scale, you have to go and kind of do some backflips to get to the right instance. But if you're running on a single instance, you're running under low load and you're just trying to figure out on a dev instance what's going wrong, you can just attach a debugger to it and it works just like debugging locally.
Yeah, but
Awesome.
with the new tools, you can debug locally with consuming resources in the cloud.
Yeah.
So we'd probably recommend that unless you're seeing a bug in production and then you have
So what do you see in the stack trace?
Well,
Like
for
I was saying,
instance,
anonymous classes and strange named things.
well, we do a lot of work to try to clean up the stack traces, so we don't cover them with a bunch of goops. We just give you what the actual exception message is there when you see your traces. If it's Node, you only see the Node trace. You don't see any of the .NET traces that end up getting rolled up from it. And then when you're actually debugging locally, you can actually go through there and break on exception. So you'll actually go ahead and just break on the exception and break on the line that threw the exception for you.
Right on. All right.
Some
Hey,
of this
Denny,
will
how
come
are you
out in
doing,
your
man?
Session, right?
Yeah, exactly. Yeah.
So, Todd, how do you test Azure Functions, unit testing, etc., before they're deployed to production?
And this is a great plug for the new VS tooling that we do have available right now. That one allows you to go ahead and write your functions as class libraries, which means that I can go ahead and use XUnit or whatever kind of unit testing framework that I want to test my .NET class libraries like I normally would before. For Node.js, it's kind of the exact same thing. I can go ahead and write something which is essentially just a module, Node.js, and run Mocha or anything else that I want to kind of do unit testing against it.
You could also do some interesting things with sort of chaos.
Yeah.
Right?
Yep.
So I could inject a fault into one of these functions and see how that affects sort of the larger system.
We've actually seen some really cool talks on functions manipulating other functions and kind of meta programming where functions are creating other functions, turning off other functions, those kinds of things. I actually had a cool example where I built a bot which created functions for you and things like that, and it manipulated itself as it went along. It's really fun stuff.
Open
Talk
source
about security holes, right?
Yeah.
I want to see that. I love that. It's a really useful use of a bot.
Yeah.
Steven wants to know, can functions act like push notifications?
So I'm not sure what question means, but we do have the concept of bindings, which means you can push data out of a function, and we have a binding for Azure notification hubs. So you can literally write a function that will push a notification to all of the mobile platforms.
I usually generally think about push as sort of like reactive, right?
Yeah.
Instead
But
of
it could be
pulling,
proactive,
push
right?
information out. Things are waiting to get it. They can either do something with it or not.
It could be proactive if you, one nice thing about functions, you can schedule them.
Yeah.
So imagine every morning you'll have a push to your phone with your schedule for the day, right?
All right, so very interesting one, misinformed DNA. Interesting name. Why does functions in the dynamic tier run out of sockets if there are too many function calls?
So the funny thing is that you can run out of sockets in the dedicated tier as well, but since in the dedicated tier you're running on much larger VMs, it's much harder to get to that point. Essentially in the dynamic tier, you're running in kind of smaller envelopes of compute, and so you can run into those limits a bit faster. Normally what happens when you're running into these problems is you're not properly utilizing connection pools under the covers, and so the same way that this would eventually break down on a normal dedicated server, you're not utilizing the resources as efficiently as you could. The same thing can happen in the dynamic compute, where essentially you want to reuse those sockets as efficiently as possible, and when you're done with them, make sure that you actually dispose of the connections so that way something else from the pool can start to use those sockets. And just the same way that I said you should try to use a connection pool, wrap it in a factory, and use that from all your functions, that is a best practice for any outgoing connections you're trying to make, regardless of database, HTTP, etc.
Right on. Is there a hands-on lab or other training tool for getting started creating and testing functions?
So this morning we actually launched a new set of quick starts on the docs.microsoft.com /Azure. And there's scripting examples that get your functions up and running. And you can copy and paste those into our new cloud console in the management portal and get going to there.
Right on. It's interesting because docs.microsoft.com is Jeff Samquist and Dan Fernandez's new thing. It's funny how things go around and around and around.
Runs on
really
app
nice
service
stuff.
as well.
I like Docs.
Yeah.
Can you host a WebSocket service in Azure Functions?
Right now, you cannot basically have WebSocket requests made to Azure Functions and have WebSockets trigger on them. It's something that we're investigating. It's kind of a tricky piece because it's basically a stateful connection, right? And so we have to have an instance, and we have to have any other executions that want to send outgoing requests to that WebSocket talk to that instance. So it's possible, but there's some engineering challenges for us to face. We're keen to kind of go and look at that. One other option to look at is using like Service Bus, and basically having WebSockets request into Service Bus, which trigger your function, and then back out to Service Bus to then have it respond.
And how would that scale?
It's essentially it scales based on how much Service Bus scales, and so you might have to do some service discovery thing where you kind of tell each client which Service Bus it's going to go to if you do need to scale beyond like 30,000 clients at a time.
And obviously your state provider is where you can have a bottleneck.
Functions will scale behind the scenes just fine. It's the Service Bus itself you have to worry about sharding that.
Understood. Well, I mean, there's a lot of people that actually do IoT stuff, right? You have IoT devices sending data up to functions. That do what they need to do, stick it in a database, they're done.
And that's our largest scale stuff today. Like the people who are doing 1 billion executions a day are generally doing IoT scenarios where they're just sending us tons and tons of IoT data, and they're generally doing multiple steps of processing on each message that comes along. And so they're chaining like 3, 4, 5 different event hubs together and using Azure Functions as a part of the processing, throwing in some streaming analytics, and they get a really cool end-to-end pipeline for their data.
Awesome. I mean, that's actually like the canonical use of these sort of small computational bursts that we call them. I mean, you're not because I think it would be quite interesting if you could somehow get machine learning involved here, right? Because I'm always running the same function over and over and over again. I should be learning something. Right? There should be some behavior that I can extract from that, send to a different function or to a different real computational fabric that'll start doing some learning on it, which you can't do in a function because it takes too long.
I mean, my favorite pattern here is actually like you'll get machine data coming back in like binary form. Like you want to really compress and condense that message. You'll go ahead and explode it out into a JSON message with a function, and then plop it into another event hub, which will then go to Stream Analytics. And Stream Analytics does have the ability to go ahead and do kind of real-time stream processing, machine learning on those things, and really it helps. Like basically, you can use functions to help extend your whole pipeline and make all the things kind of work together.
Awesome. So they're literally anonymous functions in some sense, in terms of, not in the strict sense, but the way that I have a certain fixed amount of computational, computation.
Yeah.
Now I want to add other things around it. It's as easy as just writing a function.
Yep.
And I think that's kind of one of the amazing things of serverless computing. And we're going to continue to see this spin up into much more interesting scenarios. So, like, can you guys, as we end here, I know we have some more time. We are running out.
Yeah.
Kind of give us your vision on where you see Azure Functions, serverless computing going in, say, the next couple of years, because we're at like internet speeds now and cloud speed.
So I think that we've seen a great articulation in the keynote with the intelligent edge stuff. But really, we sort of went to the cloud, but now we have all these devices that are pretty robust as far as computation, right? I have more CPUs on my body than I had 20 years ago.
I can see
right?
that.
The capability, yeah. And those things are now close to data, right? We consume all this data, so where data is, compute follows, if you will. So we think that the function as a service programming model really lends itself well to these intelligent edge scenarios because you really don't care about what you're running on, and you have this abstraction between data coming in and data going out. So I think that's definitely one area where you're going to see functions play a big role. Another interesting place is what we, for lack of a better term, is VBA for the web, right? So all of these software as a service solutions that provide really useful business scenarios, they all need some kind of an extensibility model. And we're already seeing it with some of our customers, and we'll see more with first-party customers, where you can use functions to extend your business applications. So I think that's another area that you'll see happening. But for us as a team, I think the most exciting thing is that we don't know. You, the customers and the devs out there, please tell us what you want to build, and we'll support you.
Yeah. I'll call out, we are open source.
Yeah.
You are open source.
And so if you would like to see what we're doing, potentially contribute, you can go ahead and check out github.com/Azure/Azure-functions, and you can check that out.
Cool. Well, we have to wrap up.
Yeah.
Thank you so much for
Thanks for
having us.
riding with the
Great job.
tandem. Random with the tandem.
Yeah.
Hey, man,
Thanks so much.
you.
Yeah.
Great job, guys.
Thanks.
It's very cool stuff.